All right, sorry about that. A little hiccup there. And do I want this to be listed or unlisted? Oh, there it is. I'll make it public. Okay. Maybe people join. Like I said, this is good. So welcome everyone. This is a live stream of me building a multi-data center EVPN VXLAN fabric with Arista AVD, doing it from scratch. So showing you not only how I do it, but actually how I assemble all the things like the data models, the files, inventory files, etc. And also just playing around with this streaming stuff. I'm also doing all right, start over my intro. Okay, welcome everyone to building a multi-data center EVPN VXLAN fabric with Arista AVD, kind of a mouthful there, from scratch mostly. So the goal of this is we're going to build from a basic config. So basically we've got just basic authentication, NTP, DNS, and that's it. There's no underlay, there's no overlay, there's no anything on here that's going to build as a fabric, and we're going to end up with a fabric. Now, I don't know how long this is going to take. I'm going to cut this at about an hour. And if I think about it close to an hour, like 40, 50 minutes, then I'll do a part 2 at another time. But, so what this is going to be is, one of the challenges when dealing with Ansible, I think for a lot of network operators, people who are starting the network automation journey, is how do you do all these things with playbooks, and how do you create the inventory files, and what variables do you put where? Ansible is a really great tool, but one of the kind of the frustrations I think is that there's about 1 billion ways to do things in Ansible, and so you can take a look at 2 different tutorials, and they all put their files and stuff in different places. So this is meant to help with that. Another thing is I see a lot with the AVD demos, they don't show how all those files were created. So I wanted to do something to address that, to show you how I go about doing these things, and not only just the implementation, but the designing of the network itself. So we've got here, one of the tools that we'll be using with this is VS Code. So this is actually an implementation that Arista has built into their lab environment. So it's actually VS Code as a web application. It's called Coder, and it's open source. VS Code itself it's what's called an IDE, and it's a file editor, file manager, and does things like linting, which is kind of like spell check for syntax. It'll tell you if your YAML's messed up. And this is one of the tools that we're going to be using. And we've got a Unix or Linux server here, and we can see we're running Linux here. So this is going to be our control node. So that's the Ansible control node. We also have Cloud Vision. And see my passwords here. These are randomly generated lab passwords, so don't get too excited. And we're going to be using Cloud Vision. Let's take a look at our environment here. So here's our data center that we've got right now. We have 2 different data centers. We have, make sure I get everything in the screen here. We have 4 leafs in each data center, 2 border leafs, 3 spines in each data center, and they're all connected through a DCI router between the 2 of them. I've got 4 hosts. Now these are actually EOS devices. And what they're going to do is they are going to be they're actually EOS devices, but they're going to pretend to be hosts. So rather than Linux server or Windows server, and some people don't know how to use those, or someone's more Linux oriented or someone's more Windows oriented, we just went with EOS. So these are going to be our fake hosts. We're not going to run any routing protocols, or we're not even going to configure these through automation. We're going to configure these manually, the old-fashioned way. But the rest of this, we're going to build out an entire EVPN fabric through automation. And we're going to do it mostly from scratch. I've got some notes to like copy and paste and stuff and cheat a little bit. But so yes, that's our topology. I'm going to make another one here. This is going to be our EVPN services. Now, in So EVPN is what's known as a multi-tenant environment, and we tend to think of that as like Coke and Pepsi, putting them on the same platform and making sure they can't see each other or mess with each other. But really, what multi-tenancy can also do is there are security zones. So they're administrative security zones, and then we use VRF for forwarding security zones. So we're going to have 2 VRFs here. And that'll be VRF red is one of them. We'll go ahead and make that red. As you can probably tell, I spent a lot of time in PowerPoint and also Google Slides. Oops. This will be VRF blue. We'll change that to blue. Just a little razzle dazzle for you there. So red and blue. I'm sorry, tenant. Tenant red, tenant blue. Because we are also going to have a VRF in each one. So tenants are interesting because they don't show up anywhere in the config directly. They are a administrative domain that sits outside of the data plane and control plane. So they're a policy thing. So that'll be red, that'll be blue. Do that in the top. Nice little command that you can do is if you do the F4 command. Like if I change one thing and I do it to the other, change one object. Like I set it to, it's middle now, and I want to set it to the top. Then I can click on the other object and hit F4, and it will do the same thing. So this one will be VRF. Move this over. Call it red 1. This will be VRF blue 1. Super creative names, I know, but let's make those blue, make that red. And then in terms of our services, we're going to have, so that's and these will be actually in EVPN parlance, these are going to be the L3 VNIs. Because we are going to be, this is going to be symmetric IRB. Now we have to do this before, it's good to plan these things. So we're just going to take a few minutes to plan this out. We're going to have the list of hosts that we're going to have in here is going to be host 1, DC1, and host 1, DC2. So they're going to be connected. Do a slightly different background for that one. Oops. It'll be host 2 DC1 and host 2 DC2. So the two tenants are going to be, each tenant's going to have another node in a different data center, just so that we can prove that everything's working here. All right, so we got that, and then we just need 2 networks. We're going to put 2 networks in here. So let's do another color. Let's do green. So this will be, I'm going to put this up here. Try to be as clear as I can in these things. And I'll kick down the font a little bit. And this will be VLAN 10. Now, one of the things that they talk about with EVPN is that you get like 4 billion networks. Or not 4 billion, 16 million. 16,777,216, I think, or 214, one of the two. We don't really get that actually, because one of the things that you have to do is when you have a VXLAN segment called a VNI, then it needs to be assigned to a local VLAN on the switch to forward the layer 2 frames. So what we end up with is every VNI needs a VLAN. And the VNIs are globally significant, but the VLANs are locally significant. But we really are just going to treat the VLANs as if they were also globally significant. So every VLAN on every switch is going to be tied to the same VNI. You don't have to do it that way, but that's the way you have to do it with AVD. And if you don't do it that way, then it gets really confusing very quickly. So I'm going to put host 1, DC1 in here. And host 1, DC2 in here. So we'll get rid of that. Copy and paste. A lot of copying and pasting in this job. We are going to have this is going to be an Anycast gateway. So that'll be our default gateway. This will be 10.1.101. Now, because these are VRFs, we can actually overlap the IP space, but I'm not going to, just to keep them differentiated. But you can certainly do it. The data plane and control plane don't care. They're more than suited for that particular task. So VLAN 10 and 20 for tenant red, and then VLAN 100 and 200 for tenant blue. I think that's about all we need to do in the services part. We do need to make a couple of choices for our topology. For example, I'm going to need some AS numbers. So what I'll do is I'll just make a simple notation here. So AS number will be 65,000 here. For the border leafs, that will be 65,199. For the spines, so this is going to be eBGP. This will be 65,100. And then we can actually give, one of the cool things about AVD is that we can give a range of ASNs and it will automatically assign them. And then we're going to do the same thing over here. Kind of keep the same numbering going on. The third digit's going to represent the data center. I mean, if we wanted to use 4-byte ASNs and as.dot notation, we could do that too, but I'm a little lazy right now, so we're going to do it this way. 65299. All right. It's almost 10 o'clock, so I doubt anyone's going to be watching this live, but in case you do, it is live. All right, so we've got our AS number assignments. We need a couple other things. So one of the challenges and one of the reasons why automation is so important for EVP and VXLAN is when we're doing BGP as the underlay, each one of these links needs a unique address. So every one of them, so make this nice and big. So for example, that link and that link right there from spine 1 to border leaf 1, we need two addresses, 2/31s to do a point-to-point connection because we are doing BGP in the overlay and the underlay. That's another choice we've made. eBGP in the overlay and underlay is the default for AVD. It does allow us to do something different other than that, but we're just going to do that for now. It's the easiest one, and the only reason not to do eBGP, I think, in the overlay and underlay is if you were labbing it, typing it by hand, I would use OSPF as the underlay because it's way simpler to configure. But AVD is doing all the hard work for us. So we need some other addresses. And so for DC1, we need point-to-point. And what we're going to do is give it a range of addresses, and it's going to chop it up into /31s. We also need loopback 0. So we'll do 1 and 2. So this is going to be our for router IDs and for overlay peering. And then I need our VTEP IPs. We use loopback 1, and that's because these devices, these switches, leaf 1 and leaf 2, they are actually going to be in leaf pairs. I'll call them node groups. So every one of these leaf pairs we're going to set up MLAG. We could also do EVPN multi-homing, like with setting up ESIs, but we're just going to do MLAG because that's the simplest. We don't have any particular reason at this point to do anything different. So these AS numbers are going to get assigned dynamically to each of our leaf pairs that are going to be in an MLAG group. And it will automatically configure all this for us. So I'm going to do this all without going into the CLI, with the exception of the host, because the host, when we automate, hosts are not automated by the network automation. Even if the server team uses Ansible, and even if the networking team uses Ansible, you're typically going to use two different control nodes, two different system setups, etc. So they're going to have theirs, we're going to have ours, and so I'm just going to go into these each individually and configure them manually. So for DC1, we need these addresses set. I'll just shrink that down. And then for DC2, we'll just change the third octet. Pretty standard stuff, and trying to find clever ways to encode the data center into the numbering scheme. So pretty simple there, pretty basic. So I think that's about it. If we need anything else, we'll come back, but we'll do this for now. You know, when we get into automation, there's going to be more planning ahead of time. Now, if you're going to do EVPN, then you should absolutely, even if you're going to do it manually, which I don't know why you would, even if you're going to do it manually, you're going to want to do this kind of planning ahead of time, and you're going to want to get out a spreadsheet and do your point-to-point links. I'll probably go crazy in the process, but here we're going to be lazy, and we're going to let AVD do most of the work. So we've got our physical topology here. We've got our EVPN services here, and now we are ready to get this thing started here. So I'm going to have a directory. I'm going to make a new directory, call it AVD multi-site. Actually, you know what? I'm going to do this. I'm going to rename this to live stream AVD from scratch. And I will make a GitHub repo, and I will put this on GitHub, and you can take a look at the final results. So I'll sync this up when we're done. So, okay, so we got this going on, and so our directory here, the first thing we're going to need to do is create an Ansible config file. We don't need to go super fancy here. I'm just going to cut and paste one. The other thing I'm going to do is I'm going to try to do as minimal as the number of files and everything as we possibly need to get things done, to get this thing built out. So we're not going to do any flourishes or anything super extra fancy, although we will get a little bit fancy when it comes time to doing the DCI, because we've got a couple of approaches to that. But this is going to be, I'm going to try to make the most basic one that I can. I do have a GitHub repository for my work account, or for my SDN Pros account. So you can find me. Let's see if I'll put it in the chat room here. Can I do that? Yeah, I'm going to post this into the chat room. I have a GitHub account. You should take a look. Got a bunch of stuff in there. So most of the stuff that I do with Arista, I put in here. So there you go. I think it shows back up in the stream replay. And it's just Tony Burke, SDN Pros, all one word. Burke, B-O-U-R-K-E. All right, so so our Ansible config file is going to be very simple. I'll just go through a couple of things. Host key checking is false. We actually don't need this. This is if we were going to use... actually, I'm going to leave it here. I'm going to leave it in. We don't really need it because we're going to use eAPI. We're also going to use CloudVision. So what's going to happen is that AVD... Let's actually take a step back. What is going to happen? copy this graphic from another slide. So we've been talking about Arista AVD and you're probably kind of wondering what it is. It is it's a Ansible Galaxy collection. So it's a collection of modules. It's got built-in roles and data models, Jinja templates, etc. And we're going to build the configuration for all of this. So out of just 3 files, we're going to build the configurations to all of these. We're going to document them. It's going to automatically, dynamically create a living document about the various settings for each of these devices. Then we're going to deploy it through CloudVision. We can also deploy directly to the switches, but we're going to go through CloudVision because we have some pre-deployment validations that are handy there and some other benefits. And then we can actually run some tests. And to run the tests, we need to be able to log into the switches and run some commands. And there's 2 ways to get access to the switches. We can either get in through the CLI or we can get in through the Arista EAPI. If we're going to go in for the CLI, if this control node, so this Linux system right here, IMA control node, is the Ansible control node. So this is the device that's running all of these Ansible playbooks and so forth. If it has never SSH'd into one of these switches, you're going to get an error that looks like this. Right here, this error right here. If Ansible sees this, it will fail. It will not continue. So unless you put this in here, which says don't worry about this. Now there's, from a security perspective, there's a lot of interesting things that you might want to do so you don't get this, because you want to pre-share your key or something, but we don't have any of that set up here. It's just a lab. Our inventory file is going to be inventory.yaml. We have some Jinja extensions to do some extra stuff. We need that. And then gathering is explicit. Whenever we run a playbook against the device, in this case we're just going to do it primarily against CloudVision. Anytime that we do run a playbook against the device, it's going to gather some facts. And they're not really useful to us, and it takes time. Things like what version of Linux are you running and what is your network interfaces and a couple other things that we're not going to do anything with. And there's not that much we can do with it. So it's going to say, don't gather any facts. Don't bother gathering that fact. It's just going to waste some time. All right. So that's our Ansible config file. The next one, again, I will upload these on the cloud into GitHub. The next one is going to be our inventory file. Now, a lot of these network automation platforms, are going to need some kind of inventory file. So Nornir needs an inventory file. Ansible needs an inventory file. There's even ways you can make them dynamic, but we're not going to do that. We've got a pretty static environment here. And so what we need to do is basically we need to tell we need to tell Ansible about all these things. We also are going to need to do well, first of all, there's another device out here that we've got to work with, and that's CloudVision. CloudVision is Arista's network automation platform. And you can use it as a completely self-contained system to generate configurations, apply configurations, etc. Or you can use it in conjunction with another setup that's going to generate the configs, and then CloudVision will apply them. So the first thing we need to do is we need to tell Ansible about CloudVision, because Ansible is going to be mostly working with CloudVision. The only part about Ansible that's going to go to the devices individually, to the leaves and spines, is going to be when we're doing the validation tests. So I need to find my... Yeah, so I'm going to... So it starts with all. Actually, so we're gonna use this in a file type called YAML. You can also do YAML. YAML is what's known as a serialization language, and serialization languages were initially meant to exchange information from one device to another device. So XML and JSON are both examples of serialized languages. It's it's also used to describe the way we want things to look and to describe things for various programs. YAML is great because it's human readable. It's very readable, but it's also structured, so it makes it very easy to work with scripts. So we're going to start with all. We're going to create a group called all, and we do this in groups. And well, let's do a visual representation of this because I think this will help out. There's two different types of inventory files, INI and YAML. We're just going to do YAML. It's the better way to do it. I used to teach the INI method, but I think this is just a better idea. All right, so we've got a group, and this group is going to be the same thing. Move it over here. So we have a group called all. The next thing we're going to do is create another, we're going to create a subgroup. So just a grouping of devices. And this one's going to be called CVP cluster. Now I could call this hyphen cluster, but Ansible really doesn't like hyphens. So we're going to try to avoid hyphens as much as possible. And CloudVision normally runs a 3-node cluster, and we actually only have to tell it about one of them because there's a lot of these new setups, scenario, or a lot of these new clustered management systems that rather than being active standby, they're active, active, active. They've got a quorum, which means you need to have a majority of them active in the node to be active. But you can make an API call to any of them. You can make a config change to any of them. So we're only going to tell it about one of them. So we'll do the host is CVP1. Now, again, we don't have to tell it about all of them. I mean, actually we could, but we're not going to, because we can specify one of these in the play. So that's one group. We're going to split things up. Like AVD has these things called data models, and they are how we describe how we configure devices. So we're going to have a data model, and we have to mirror them with groups in Ansible. And one's going to be called Fabric. And Fabric is going to have all the devices in it. And then inside of Fabric, we're going to have DC1. So that's going to have things like the definitions of our spines and leafs. Leafs, spines. So those will be subgroups. And they'll have another one for DC2. So leaves and spines there. We're going to define our DCI config in here as well. So DCI is going to go in here. Actually, no, that'll go right here. DCI. Then we've got this, and then we've also got two other YAML files that we're going to have, and one's going to be called EVPN services. That's going to describe our tenants and VRFs, and another one's going to be called endpoints or endpoint connection. So these will be files. And inside of these files, we'll have all the different parameters that we're going to use to describe what we want to end up with. And then Ansible, AVD will take that, run the plays, and get these into... Yeah, so that's what we're going to do. All right, so we're going to describe this in YAML, in the Ansible inventory file. So we'll do CVP cluster hosts CVP1. Now we're going to put some parameters in here. We can put them in other places, but I like putting them in here. And I'm going to cheat and copy and paste. So the Ansible HTTP API host is going to be .5. It's also the Ansible host. The username is this. And we're going to change the password to what we have in our lab environment, which is this right here. Now you're probably thinking to yourself, that's not a great place to put a password, and you are right. Ansible does have a way to handle this, and there's other ways to handle this too. For example, I think they might support client certificates now, client TLS certificates, or you can use something called Ansible Vault, which will you'll have to unlock the vault, and this parameter will be in the vault rather than just in this plain text YAML file. We're going to connect via API. We're going to use SSL, and we're not going to worry about validated certificates. The network OS is EOS. Actually, it would be probably a better apt description would be CVP. But that's what they call it. And then 443. So these are the things that we absolutely need. And again, I could describe the other 3 nodes, but we're not going to, because actually there only is one in this lab environment. I might describe all 3 of them if I did have 3, but I've only run the play against one of them, because if I run it against 3 of them, it's not gonna matter. All right, so CVP cluster, and then the next thing we're going to do is we're going to define the fabric. So we've got, and that's going to be on even footing with CVP cluster, and we're going to have some variables. And there's 23 different ways to declare variables in Ansible, and so there are 23 different places to put them. We're just going to put them here because it makes sense, I think, at least in my mind. And we're going to use, again, the eAPI. Alternatively, we could go in through SSH if we wanted to do that, but we're not going to do that. So our vars will be Ansible. And this is going to, by putting them under Fabric instead of under the host. So Fabric is a group. And because we put it under the group itself, these variables are going to be applied to every device underneath Fabric, which is what we want, because it's, for example, the user is Arista. And the Ansible password is also the same thing over here. So these are actually going to 2 different APIs. CloudVision has a REST API, and eAPI is actually a JSON RPC API. So they're similar in that it's a programmatic interface, but they're different ways to go about the same thing. Okay. So we'll steal a couple of these things. I think I just copy these. If you do control left bracket, it'll automatically indent, and then control right bracket will, I'm sorry, control left bracket dedents, control right bracket indents. Enable. Ansible become. I'm reading some from notes. I don't have all this memorized. Yeah, I think that's it. Okay, we're good. So this will allow us to log in. This will tell Ansible how to get into the individual switches when it's time. And then under the fabric, we're going to have some children, which means there's going to be groups within groups. And the first one is going to be DCI. That doesn't like when we have a group called DCI and when there's a host called DCI, but we're going to ignore that for now. And this is going to be what's called a super spine. And there's only one of them. And its host address is 192.168.75. We generally don't need to put that in there. because we do have it in DNS. So that's DCI. And then our next one is going to be DC1, Data Center 1. And then under Children, we're going to have DC1 Spines. And then another one called DC1 Leafs. These names need to be unique. I don't think Ansible cares if they're unique, but CloudVision does. So these names do need to be unique. So that's why I'm not calling it Spines and Leafs, because DC2 will also have Spines and Leafs. DC2 Spines and DC2 Leafs. One of the things you can do in Ansible is, so under host for DC1 Spines, in Ansible lets you do this, Spines 1 through 3. Don't do that in AVD because it messes things up. So we do need to define them individually. And then again, we're going to put in some IP addresses. Spine 2, DC1. Copy and paste. Control left bracket to get it all there. Change that. That's spine 3. All right, so the rest of this I'm just going to copy and paste. Oh, another thing I want to do is vars. And it's just telling Ansible that these are of type spine. So it uses the spine, spine-based templates. So for here, I'm just going to cut and paste. So we are also going to have vars, and these are of type L3 leaf. There's also, you can do an L2 leaf, but we generally don't do that. The difference between an L2 leaf and an L3 leaf is that with an L2 leaf, there's no anycast gateway. It's purely layer 2. And we're typically hanging that off of an L3 leaf, but we don't have anything like that. I'll do, again, I'll cut and paste just to save us some time, because I don't think you want to watch me typing. And I've got to indent correctly. Ansible is very picky about its indentations. So we need to make sure that we have everything indented correctly. Don't you worry, it will let us know if you didn't. We also need to set up our EVPN, how we connect our EVPN services. We'll do this outside of Fabric. So EVPN services, and then we want to build configurations under DC1 leafs. I did say they do need to be unique, but you can copy them here. So like I said, there's what's called a linter, linting. That's that squiggly line that just basically tells you that I did something that YAML didn't like or Ansible didn't like. So the services config, that's the VXLAN configs, the VLAN configs, the VTEP configs. They only go on the leafs. So they're going to be defined in here, and then they'll be generated for the leafs. And then the other one was, what we're going to call that, endpoint connection. That's how we're plugging into, endpoint connection is how we're plugging into the fabric. And then same thing, I'll just cut and paste here. DC1 leafs, DC2 leafs. All right. So we're done there. That's we've described the inventory, hopefully to Ansible's satisfaction. It's I don't see any linting errors, so our YAML looks good, and it also checks for Ansible syntax, and it looks good there. Not to say that there's not anything wrong, but we probably caught most of everything. Now I'm going to need to create a couple of directories here. One's going to be playbooks. That's where we're going to put our playbooks, of course. Another directory is going to be group vars. So this is where we're going to put our YAML files to describe what we want the fabric to look like. And the rest of them will be dynamically generated. So we're good here. So we'll start with describing the network. So under group vars, we're going to create a new file called dc1.yaml. That must match this group here. So this group name is matching here, and this is going to be how we describe DC1. We're also going to have fabric.yaml, that's the root. And these are going to be things that apply to everything in the fabric. And then we'll also have DC2. Doesn't really matter what order you create these files in. EVPN services.yaml, and then again, it's got to match what's in inventory. Endpoint connection. We'll just copy that. Go to group vars. Endpoint connection.yaml. Oh yeah, and DCI. All right. We'll start with fabric, and we'll just start telling the fabric all the things it needs to know. The first thing it needs to know is what its name is. And we're just going to call it fabric. Super original. We're going to start specifying some options here. We are going to use VXLAN aware bundles. You don't have to use them. And where I'm getting this from is the documentation. The AVD collection documentation. So it's avd.sh. If you go to roles documentation, designs, and if we go to fabric variables, this is where I'm getting all these variables. Things like what underlay routing protocol do we want to use, overlay. There's some defaults, like the overlay and underlay default routing protocol is BGP, so we don't have to specify that. Point-to-point links, uplinks, we'll set the MTU globally, and we'll set that to 1550. Because this virtual environment doesn't deal with like the super high jumbo frames, it's all running as containers in Linux. We've run into some issues with super high MTUs, so we'll just do 1550, which is enough for our endpoints to have a 1500 byte MTU. I've got to put some stuff in for the lab environment, my lab environment, but you might not want to. You might not need to do this. So that's it, basically. See if I need anything else. Yeah, that's it. You may need to put some stuff in your environment, especially if you're not using AVD. All of your configs will need to be coming from these. So I might put in things like DNS servers, gateways, etc. But we're not going to worry about that. So the next thing we need is we'll go to DC1. So in DC1, it's a YAML file, so we start off with 3 dashes. And then we'll just start defining the spines. We can set some defaults for all the spines. For example, they're all going to share an AS number, and that's going to be 65100 for leaf 1. Then our loopback IPv4 pool, this is going to be for loopback 0 and used for underlay peering. And that's the IP address that I already selected for loopback, yeah, 101. I can put in some just raw configs, raw syntax. Don't put that in there. Make things a little bit cleaner, a little bit easier. I don't think we really need to do this, but I'll go ahead and leave it in there. It's in every style guide or every guide. And because we're doing layer 3 leaf spine, we're going to build out an EVPN fabric. We're not going to do MLAG on the spines. Now, you can actually build out a layer 2 leaf spine fabric, so there's no VXLAN, and it's just SVIs and gateways. In that case, the spines do have MLAG in them. because they're the aggregation or core switch, core aggregation collapse core. Under spine, we have our nodes, and this is where we'll define our individual nodes. Spine 1, DC 1. Every node needs an ID. Now, and we'll put in a management IP address so it can actually generate the management config. Especially if important if you don't have CloudVision applying other parts of the config that include a management address. We actually do, but it's I'm going to leave it in here. That way you don't lock yourself out because you applied it and didn't have a management address. And again, I'll just copy and paste. The IDs in the data centers need to be unique because it will use this ID combined with this pool is going to be how it assigns loopback 0 addresses. So they do need to be unique at a data center, but a different data center is going to use a different pool, so your IDs can overlap there in different data centers. All right, so that's our spines. That's it. Layer 3 leaf. Defaults. So we'll do BGP AS, and we'll give it a range. We don't have to give it a range, but we'll go ahead and give it a range, 65.190. Our loopback IPv4 pool, same pool, but the IDs will be different for our leafs so that we won't have an IP collision. Our VTEP loopback IPv4 pool is going to be 102. So that's our VTEP addresses. Uplink interfaces. Now these are the interfaces that we're going to use to uplink from the leafs to the spines. When we're describing our connectivity, our physical connectivity, we do so from the bottom up in AVD. So if we go back to our diagram here, actually we'll go to this one. A little bit hard to read here, but it's 3, 4, and 5, and fortunately it's consistent across all of these devices, which makes our job easier. So I don't have to do some one-offs, although you can. So Ethernet 3, Ethernet, we can put these in a list. We can tell it's a list because we're putting it in brackets. So lists aren't leaf spine pairs, or just items. Could be strings or integers or whatever. And then our uplink switches will be a list, spine 1 DC1, spine 2 DC1, spine 3 DC1. We're also going to need an uplink IPv4 pool. And these are for our point-to-point connections like I talked about earlier. And we'll give it another one. If you have a really large fabric, you're going to need to give it bigger than a /24. But we only have a handful of devices, so we don't really need to worry about that. We are going to be doing MLAG. So we're going to need to set up some things. For example, our MLAG interfaces. It's also consistent, Ethernet 1 and Ethernet 2. On all of our leafs, that's why we can put it here instead of individually. So if we take a look, it's just 1 and 2 between the leafs. And the same thing for the border leafs. That makes things easier there. MLAG peer L3 IPv4 pool and MLAG peer IPv4 pool. So what these are, when we're doing MLAG, every site needs to have an IP address in order to do the peering, and it typically gets put on a high VLAN, something like VLAN 4094 is interface VLANs, and then peered across the peer link. It's just the way MLAG is done. It's very similar to VPC in the Cisco world. But we need to give it a subnet. So I'm going to do 192.168.0.99. kind of a waste. We don't really need that many. We'll do 90. And then also, we're going to put some IP addresses across that link because we're going to want to have an IBGP peer between the leafs. Because what we want is, if we have uplinks or downlinks go down, we want to be able to reroute over the peer link for the layer 3 stuff to make sure the VTEPs are available even if the uplinks of a device are down. Do 91. They don't need to be that big. We're going to do virtual router MAC address. And this is going to be the Unicast VMAC. We'll put some BGP defaults in here to match our spines. Copy a couple other things. All right, so that's our leafs, our general config, and then we also have our node groups. And node groups are the leaf spine pairs, or leaf pairs rather, in MLAG. Call it first DC1 MLAG 1, nodes, leaf 1 DC1, ID 1, management address, management IP, 24, and then our uplink. Yeah, what are my, I think I can, yeah, these are all going to be, so these are the interfaces that I plug into on the spines. And if I look at my diagram here, on spine 1, I plug into E2. On spine 2, I plug into E2. And spine 3, I plug into E2. So it's consistent. Okay, and then I'll do the same thing for leaf 2. I'll just copy and paste that and then show you something. All right, so leaf 2 DC1, ID 2, different IP address. The interfaces are different because, again, if we look at our diagram, leaf 2 connects to 3, 3, and 3 on the spines. There we go. And I'll just cut and paste the rest. Actually, I'm just going to do... Well, we'll do the border leaves too. Now I'm specifically setting the AS number because when I'm doing my DCI, I'm going to want to have a static AS number instead of dynamically set. And get rid of this for now. We'll come back to that in a minute. So the border leaves are also in an MLAG pair. Although they don't really need to be. Okay. Oh yeah, these need to be indented. Ansible will care. So that's how we define DC1. DC2, I'm going to do it real quick. I'm just going to copy and paste for my notes because it's going to be the same thing. Just the other side. DCI, we'll get to that in a minute. We're just going to do, I think we just might do one data center for now. How long have I been streaming? Yeah, almost an hour. So, yeah, this is going to definitely be a two-parter. We will build out one data center, though. Endpoint connection. This is how our endpoints are plugged in. Three dots, or three lines, rather. Servers. Now we're going to define the servers, but not because we're going to automate the servers. This is how we're going to connect the servers. So type server ports. Server ports are just for NIC 1, NIC 2, NIC 3, NIC 4, just for purposes of documentation. But switch ports are important because these are the ports that we're plugged into on leaf 1 and 2. So that'll be Ethernet 6 and Ethernet 7, Ethernet 6 and Ethernet 7. Again, we go to the diagram here. It's hard to tell here, but it's 6 and 7 on leaf 1 and 6 and 7 on leaf 2. It'll be an MLAG dual-homed connection. And on those switches, we're leaf 1, DC1, leaf 1, DC1. That's Ethernet, the first Ethernet 6 and 7. And then it's leaf 2, DC1, leaf 2, DC1. And that's our second set, Ethernet 6 and 7. It's going to be just VLAN 10. We could put a list in here, but we're just VLAN 10 because the mode's, it's going to be an access port. We're not going to do anything fancy here. And then spanning tree mode, spanning tree port fast. That's going to be edge. So it will do port fast on the port. And then our port channel. Host 1, DC1, just for documentation purposes. And we'll do LACP, that's mode active. And then I'll do the rest of the hosts as well. Copy and paste. I know I said I've been doing it by scratch, but I'm kind of cheating here. So I don't think you want to watch me type everything out. I think host 2 is, that's why we have documentation. So host 2 DC1 is going to be a VLAN 100. Host 2 DC1. Oh, I did it wrong. This will be 100 here. 100. Access port, edge, host 2 DC1. Pay attention to your linters. They will save you some trouble. Host 1 DC2, that's going to be on VLAN 20, and this will be a VLAN 200. Everything else looks good. And finally, our services. Like I said, we're going to do 2 tenants. Tenants. We have red as 1 tenant. We need to define a MAC VRF VNI base. Do 10,000. I tend to like VNIs to be above 4,000, just so we know when we see an ID that we know it's a VNI versus a VLAN. But you don't need to do that. Just my personal preference over the years. May even end up dropping that. So what we were going to call that one. Red 1. Red 1, the VRF VNI. This is the L3 VNI. We'll make that 10. Kind of breaking my own rule there. Or if we run it, yeah, let's leave it there. SVIs. And then here we just put them in. We just do 10. Name, we'll call this DMZ. Enabled true. And then we'll have our IP address virtual 10.1.10.1. I'll just copy and paste. VLAN 20. Oops, VLAN 20. Now these SVIs do need to be unique. And then I'll do another tenant. I'll just copy this, paste it like a template. You do have to be careful when you're copying and pasting. So this will be blue, 20,000, 20, 100, 200. Oh yeah, we'll call this internal. All right, that should do it. All right, so it took us a little while, but we've just, and we haven't configured anything yet, but we've just described how we want the network to look. Under playbooks, I'm going to create a playbook that this is all the hard work. This is most of the hard work. Oh yeah, group vars needs to be, I was in the wrong place. There we go. It needs to be parallel to playbooks under the live AVD from scratch. We're going to create one playbook called Simple Playbook. Come on. Build fabric.yaml. Refresh this. There we go. Don't know why it's doing this, but there we go. We just need to refresh the whole thing. Let's do that. Yeah, there we go. All right. So all the heavy lifting is already done. So the playbook is just going to need to call a few things. It's going to be a playbook with a single play. The play is going to be build fabric configuration. Hosts will be fabric. We're not running it against any host. This is just running the templates against everything under fabric. Tasks is going to be generate AVD structured configs and fabric documentation. And we're going to import a role to do it. The name of that is Arista AVD EOS Designs. So these are going to build structured files, YAML files, and then the next one is going to be build EOS syntax from structured configs. That's really what we want. And the role for that one is Arista AVD EOS CLI config gen. It's going to generate us EOS syntax. All right, why is this complaining? Yeah, that one's done. Trailing spaces. Doesn't like trailing spaces. I don't know what it's... I don't know what it's complaining about. We'll figure it out. We'll find out in a minute here. So I'm going to go here, open up a terminal. And then I'll do Ansible. Let's, first of all, Ansible Galaxy collection list. See if we have AVD installed. We do. We have CVP installed and we have EOS installed. CVP shows up as 0 and I don't know why. It's just the image that this thing was built in. So let's run a playbook, Ansible playbook. Playbooks build fabric.yaml. It's going to take all this information that we gathered, that we just put in here. We'll see if we have any errors. And then we have our intended configs. So it's building out these YAML files, structured configs, and then it'll build us our EOS syntax from those. So it's a two-step process. Structured configs first, then the EOS syntax from that. And you can see it's generated quite a bit of config for both data centers. That's all it took. And then we'll do another playbook that is going to deploy. And I like to keep I like to keep the build and deploy playbooks separate, though you can put them into the same playbook. So another one, we'll call this deploy fabric.yaml. Now we have two options to deploy in order to deploy these configs. We can either deploy them directly to the switches, bypassing CloudVision. In that case, you wouldn't even need CloudVision. Or we could, in this case, we're actually going to deploy these as configlets to CloudVision. And then this will tell CloudVision which configlets to apply to which devices and then apply them. And then we can run a change control. I really like the change control process in CloudVision, so we're going to do that. We're going to run it against CloudVision, CVP1. We're not doing the cluster. We're just doing the individual node in the cluster. Tasks. The first one is going to be, it's actually just going to be one task. One play, one task. Deploy through CVP. And we're going to import role. And that's, and the name is Arista AVD EOS config deploy CVP. And then we'll have some variables. Container root, we'll make that fabric. I think that's the default anyway. Configlets prefix. So we can identify them. We'll call it AVD. So it'll put AVD in front of the name. State present. I don't even know if we need to do that one. And then execute tasks false. And then CV collection is version 3. So what we're doing with execute tasks is we're saying don't actually run the change control. It's gonna create a bunch of tasks. If we said execute tasks is true, it just goes through and not only does it upload the configs, it applies them to the devices, but it actually pushes the change control and makes the change immediately. I like to go through I like to do a manual review. It does 2 different types of reviews, but I like to do a manual, just quick once over. Ansible playbook, playbooks, and we're going to run that playbook as deploy fabric. So it's logging into CloudVision. It's uploading the configlets. If we go into CloudVision under provisioning, we look under configlets. We sort by date. We can see that we've just uploaded some configlets. So this was just now. And these are the ones created by Ansible, by AVD. This part takes a minute or so, where it's configuring the devices. So wait for that for a minute. It's like watching paint dry sometimes. The first time it does, it takes longer. The next time we're just updating the files. Oh yeah, while we're doing this, we're going to log into host 1. And we're going to throw a config on here. So it's a 4-port channel across 2 devices. Channel group 1, mode active. Interface port channel 1, no switch port, IP address 10.1.10.1 or 11. And also I'm going to do IP route 10.1.20, 10.1.10.1, put in a static route there and save that config. I put the static route in because there's already a default gateway for the management stuff, and I didn't bother creating another VRF. So we'll just put that static route in. All right, I'm going to create this change control. Oh, yeah, that's not done yet. I'm going to delete this change control. Jump the gun here. It wasn't done yet. So it's still running. Like I said, the first time takes a little while. It's also, we're running in a lab environment, and the CloudVision is running on the minimum processors available, I think. Minimum processor setup. Arista's got a really nice setup for this AVD stuff, or for these test drive stuff. So this lab here is cloud provisioned. It's running on one of the cloud providers, and it spins everything up, and then you get access to it. So if you take one of Arista's ACE classes or an Arista class, this is what you get. Well, you don't get this exact topology. Like some of the classes have much smaller topologies, but it's certainly enough to get the job done. All right, still waiting for this to finish. So if this was a typical CloudVision server, then it would go quicker. And again, the first one takes a lot longer, and then the additional ones are much quicker. So every time a device is updated, has its config. Well, let's take a look here. CloudVision has a really neat has a neat concept here called the design configuration and the running config. So the designed config. Oh, did I already have something on here? Shoot. I thought. Oh, it should be fine. So we have a design config and we have a running config. The design config is what we want to be on the device. The running config is what is, and they should match. Or at least we wanted them to match. If they don't match, and we're going to make a change to make them match because we've changed our design, and then we need to implement our design, then it creates a task for every device. Okay, we're done there. Oh, there we go. We can see that we're adding a lot of lines and changing a few lines. And then we can do review and approve. And we have our design config, and we're about to deploy our intended config. So we got an error here. It's already assigned to interface VLAN. So I got to figure out what in the configlets is causing this as a problem. Oh, yeah. I did not give it different. Oh, these are the MLAGs. So one of the issues with automation is garbage in, garbage out. Oh, here's what I did wrong. I'm wondering if you're watching this later, if you're like screaming into the microphone. So this is DC1. 91, and then DC2. Garbage in, garbage out. I give it bad information. Oh yeah, I didn't change these. So do 93 and 94. Make sure I got these all set. Oh yeah, so that should be different. We're not going to join the data centers tonight. So what we're going to do is we have to rebuild the configs again. And then we'll re-upload them. That linter problem is bothering me. Oh, there we go. It's easy, like the spines it didn't change, but some of the other devices it did. If anyone's watching. Oh, we've got one viewer. I don't know if I count as myself. I did have 2 whole people watching at one point. Okay, so we built the config, and now we need to deploy it again. So this is going to be your day 2 operations. Is you're going to make changes to these files, typically EVPN services, something here, or rather endpoint connection. You're adding a server, changing a port, or something like that. It's typically where you would do it, and then you would rebuild the configs. You build them over again, and they're total replacement configs, so that it replaces the old version completely. And then the next step is to upload them. All right, we should have... The change control is already there, and it just changed what's going to be changed. And there we go. We got no more errors. Oh, no, we do have some errors. One config. VLAN interface 3009. Leaf 2 DC2. So it looks like it's just DC2. No, it's DC1 too. It's having some errors. 94.0. Trying to figure out why it's complaining. See my IP address in two different VRFs. Just to get things working right now, I'm going to... Yeah, I was going to get fancy and add this second. Oh, there's probably something I can do under the EVPN services, network services. To set a IP address, because what we're doing is the leafs and a leaf pair are peering with each other via their VRFs, and we need to do that so that in case we lose uplinks on one of the leaves, the other leaf will be accessible by the peer link. I should have generated this automatically. They are two different VLANs. Did I call them the wrong thing? No, blue. Oh, I gave it the, that's why. Copying and pasting can be a problem. So let's build that fabric again. I don't know if that actually fixed the problem, but we can take a look. We can take a look at the config before it tries to do it. What we need is for these to be in different VRFs. These two have to be in different VRFs. Yep, now they are. Because we're using the same IP address in both. That's why. We gave it the same name. Or I did. So that should fix it. This is one of those things you have, like, you have to get used to doing things and figuring out why things are done the way they are. Wow, we're an hour and 20 minutes into this. All right, that should be enough. That's adjusted these files already. And since we have this approve button, that means, so this is a really nice thing. It's one of the things that Cloud Vision does. It does a pre-deployment validation. It's checking the syntax to make sure that when it comes to actually pasting the config, not pasting the configs, but when it comes to pushing the configs to the devices, it's checking to make sure that there's no syntax errors or any other some other problems it looks for. But we're good now, so we're going to go ahead and deploy that. We're going to deploy them in parallel, which means we're doing them all at the same time. You might want to group them into like leaf 1, leaf 3, leaf 5, and then after that's done, you do leaf 2, leaf 4, leaf 6, etc. But it's a lab environment. We'll just do everything at once, save some time. So what I'm going to do now is go into this, and I'm going to try to see if I can ping my default gateway now. And I can. So we have built an EVPN fabric. We don't have a DCI yet. So Data Center 1 and Data Center 2 both work, but they're independent of each other currently, or haven't been joined. So that'll be a different stream. Let's go to leaf 1, do some spot checks. Do show BGP, EVPN summary. Oh, it says connect. Yeah, we're not really getting much in the way of routing right now. Still pushing. I guess that's why. Let's do this. Watch 1. I love the watch command. Watch 1, show IP, BGP summary. We can watch it all happen. So spine 3 is established and the others are still waiting. You can see spine 1, spine 2 are not done completing. Nope. Okay, great. Spine 2 now. It should be enough to get a BGP session going. Show BGP EVPN summary. And there we go. Now we're established. So now we've got EVPN services. If we take a look at the config that was generated, I mean, we can see it right here. It's quite an extensive config. You can see why EVPN is one of those things that you're really going to want to automate. Because this was just a handful of leaves and spines and a couple of servers, a couple of hosts, endpoints rather. So we're good to go here for now. So we're going to wrap things up for tonight. We're an hour and 20 into it, so a little bit longer than I wanted to go. But I'm going to save this. I'll put this on YouTube so you can watch it later. And And thank you for watching. Hope everyone enjoyed.